Okay, this section deals with theoretical yields and percentage yields. If you have not reviewed stoichiometry and chemical equations, I would do that before you took a look at percentage yield. So percentage yield uses mass-to-mass calculations as well as limiting reactant calculations. And then it adds one more equation, and that's the equation of percentage yield. Now the percent yield of a reaction is equal to the actual yield, and that's what you would obtain in lab. So with all the mistakes, with everything you do, it's what you actually got when you performed the experiment. And you divide that by the theoretical yield, which is the amount that you calculate using stoichiometry and chemical equations. Now, sometimes the theoretical yield, if they only give you one reactant, then you would just use that. But if they give you two reactants, you'll have to do a limiting reactant problem to figure out which is the theoretical yield. And then you'll be able to solve this problem. Now you'll multiply to make it a percent times 100. So let's take a look at this equation or this problem and see how we can approach it. So there's a balanced chemical equation which is required for stoichiometry calculations. And it says when 6.40 grams of methanol was mixed with 10.2 grams of oxygen and ignited, 6.12 grams of CO2 was obtained. What is the percentage yield? Now these words right here, was obtained, tell me that this is something that was actually performed in lab. And so this amount right here is the actual yield. So we're not going to use that 6.12 of carbon dioxide in the equation. We're going to wait to calculate, we have to calculate the theoretical yield first. Then when we calculate the percent yield, we'll plug that number into the actual yield. Now the other two pieces of information that were given, you see that it says when 6.4 grams of methanol, so this is one of the reactants that were given right here. And then you also see that you mix that with 10.2 grams of the oxygen. So this is the second reactant. So anytime you're given two reactants in an equation, this is a limiting reactant problem. So we're going to set it up, and I'll look at it in the next page, where we determine how much 6.4 grams, how much CO2 6.4 grams of methanol will make, and we'll figure out how much CO2 10.2 grams of oxygen will make. We'll compare those two answers to determine our theoretical yield. Okay, so this is the plan. We know our actual yield that was given in this problem. We need to calculate the theoretical yield. They've given in the problem the amounts of both reactants, so we're going to have to use a mass-to-mass calculation to determine which of the reactants is the limiting reactant. Okay, so here's our problem again. And remember, I'm focusing on the 10.2 grams of oxygen, which is right here, right here in the equation. And then I'm also keeping in mind the 6.4 grams of the methanol, which is right here. Now I know in stoichiometry problems I need to use a mole ratio, which I can determine from the coefficients, but it's a mole ratio. So anything I have grams for, I will need to use the molar mass, because molar mass is related to moles mass or grams is related to moles through the molar mass. Okay, so the molar masses of CH3OH is oops, darn it, sorry, 32 .042. My pencil's not working, my stylus isn't working very well. Oxygen is 32.00 grams per mole, and CO2 is 44.01 grams per mole. So that is, so with the molar masses recorded, the 32.042 up here grams per mole for the methanol, 32.00 grams per mole for oxygen, and 44.01 grams per mole for the carbon dioxide, we're set to go. So first we're going to set up a limiting reactant problem. And I'm going to start, just because it's the first one in the problem, with the CH3OH. So my goal is to figure out if I have 6.40 grams, which I was given, of CH3OH, my goal is to figure out how much CO2 that will make. So first I use the molar mass of the CH3OH, which I have written up there as 32.042. Whoops, sorry. Grams. This is CH3OH per mole. And I'm just writing the CH3OH on both of them. I tend to do that on these problems because we're dealing with two different things and I want to be sure I'm canceling out the correct thing. So now this would convert it into moles, and once it's in moles we can use the mole ratio to convert it into moles of CO2. So looking up here, what I'm looking for is CO2, so I use this 2 here. So it's 2 moles CO2, and then I use this 2 here because that's what I started with. That's 2 moles CH3OH. You can see it's a 1-to-1 ratio, so this time the mole ratio won't change the value. And then now I have moles of CO2, so I'll multiply it by grams per mole. And so now I'll solve this problem. So it's 6.4 divided by 32.042, and then it's times 2 divided by 2, so really it would just be like multiplying by 1, and then times 44.01. And I get to 3 significant figures 8.79 grams of CO2. Okay, so this is how much CO2 that the methanol makes. So now I'm going to take the other reactant, which is O2, and I'm going to start with it and see how much CO2 10.2 grams of O2 makes. So since I'm in grams, first I'm going to divide by the molar mass of O2 to convert it into moles of O2. Then I'm going to multiply by the mole ratio using the coefficients. So if we use the coefficients here, then let's see. Then I would use what I'm looking for, so that's this 2 again up here, CO2, and then what I was given was 3 for the oxygen. So I get the mole ratio off the balanced equation and I cancel. And then I'll multiply by the molar mass of CO2. And cancel moles of CO2, and I'll calculate then how many grams the 10.2 grams of oxygen will make. So 10.2 grams divided by 32 to get moles of oxygen. times 2 divided by 3 to use the ratio times 44.01 to convert moles of CO2 to grams of CO2, and I get 9.35 grams of CO2. Okay, remember from limiting reactant problems that the amount that is smaller is what is going to be produced. So this right here, because it's the smaller amount, is my theoretical yield, which makes the methanol, because it produces the smaller amount, the limiting reactant. So when you have a limiting reactant problem and you compare the amount of products that each one makes, the one that makes the smaller is always the limiting reactant, and that makes this right here the theoretical yield. So now if you recall up here, I have 6.12 was the actual yield. So the percent yield, whoops, look at what I'm writing. Okay, I was writing with a highlighter. Percent yield equals the actual yield divided by the theoretical yield times 100. So the actual yield, let me look back to make sure, is 6.12. Is 6.12 grams. The theoretical yield, which was what was produced by the limiting reactant, is 8.79 grams. So if I take the actual yield, which was given in this problem, 6.12, I divide it by the theoretical yield, 8.79, and multiply that by 100, then I get the percent yield to be 69.6%. So that's the percent, almost 70% would be the percentage yield.